Hi everyone, meteorologist Gary Woodall here, and welcome to this episode of the Mid-South Weather Musings. On this episode, we're going to talk about one of the secrets of the storms, one of the ingredients that we need for thunderstorms to form, and that's atmospheric lift. Stay tuned, episode's coming right up. In order to get thunderstorms to form, we need three ingredients. Three things have to come together in the atmosphere. First, we need moisture, humidity in the atmosphere. That goes on to form the clouds and the rain and the hail that we get with a thunderstorm. Second, we need something called instability in the atmosphere, fuel essentially in the atmosphere. And we've talked about moisture and instability in a previous episode of the Musings. Here we're going to talk about the third ingredient that we need, lift, upward motion in the atmosphere, and the role that lift can play in thunderstorm development. Now, lift, or this upward or rising motion in the atmosphere, is again a necessary ingredient for thunderstorms to form. This lift can occur down low in the lowest mile or half mile of the atmosphere. It can occur at mid-levels, maybe 3, 4, 5 miles up in the atmosphere, or it can occur in the upper levels of the atmosphere. This lift is necessary, though, to get the air started upward, the air parcels or the air blobs started upward, and then those upward moving air parcels can go on and form the updrafts, the upward moving air currents that we find in the thunderstorms. There are two broad scales of lift that we'll talk about. The first is large-scale lift, and this is the lift or the rising motion that is normally associated with the large-scale storm systems, the mid and upper-level storm systems moving across an area. Now, the upward motion in these large-scale storm systems is pretty slow. It's maybe an inch per second or so, and at that speed, it's probably not going to be enough to actually start updrafts, to start thunderstorms on their way. However, this large-scale lift can still play an important role in thunderstorm development. This large-scale lift can help cool the mid-levels of the atmosphere and help increase that instability, increase the quality of the fuel that might be available if thunderstorms are able to form. And second, this large-scale lift can help weaken a cap or a lid that might be present in the lower levels of the atmosphere. This cap or this lid is a warm, stable layer, and it can actually block updrafts from trying to form, from trying to develop. So the cap may prevent thunderstorms even if all the other ingredients are in place. This large-scale lift, though, can help weaken that cap or that lid. Now, when it comes to actual thunderstorm formation, usually we are looking for small-scale lift, and that small-scale lift will usually be associated with boundaries in the atmosphere. What do we mean by a boundary? Well, the fronts that move through the area, cold fronts and warm fronts, are boundaries, and there will be lift associated with those. Gust fronts, the leading edge of the strong winds that may rush out away from a thunderstorm, also called outflow boundaries, can be sources of lift, getting new thunderstorms forming around an old existing thunderstorm. And we're going to talk about another important boundary coming up here in just a little bit. Now, with these boundaries, especially down near the surface, the motions, the upward motions, may be on the order of several feet per second, so much stronger than the lift we saw with the large-scale storm systems. This lift is usually focused down in the lower levels of the atmosphere where it can play the biggest role in getting those parcels, those blobs of air started upward and perhaps get the thunderstorm process set into motion. And again, if the other ingredients are present, then this could be enough to initiate the thunderstorm process. Now, to identify these boundaries in the atmosphere, we often will look at surface weather observations. But boundaries are also visible from satellite. Here we're looking at a visible satellite loop of a thunderstorm day back in 2013. And early on in the loop, we see a thin line kind of coming from southeast Kansas across Missouri here, that was a surface front. That was a surface boundary. And we see early in the loop here that we did have a cluster of thunderstorms that developed off of that boundary and moved on to the northeast. Now, later in the loop, later in the afternoon, a second larger round of storms formed along a boundary from, again, southeast Kansas down through Oklahoma and into north and northwest Texas. This boundary is called a dry line. The dry line separates warm, moist air to the east from very hot, dry air to the west. So it's kind of like a front, but instead of separating warm air from cool air, it separates moist air from dry air. And especially in the spring and early summer, this dry line will often be an important factor in thunderstorm development here in the southern plains. And this second round of thunderstorms actually wound up producing the EF4 tornado, which struck Moore, Oklahoma, May 20th of 2013. So that's going to wrap it up for this episode of the Mid-South Weather Musings, a look at one of the secrets of the storm, lift in the atmosphere. If you like these presentations, like the information that we're passing along, then follow us. If you're watching on YouTube, subscribe to our channel. If you're watching on Facebook, then like and follow our page. That way you'll get notified of future episodes of the Musings when they come out. And we'll take a look in future episodes as well at other aspects of thunderstorms, some of the tools that we use for forecasting and detecting thunderstorms as well. So thank you all so much for watching. Everybody keep safe.